In this video, we will determine how a graph is either a function using something called the vertical line test. We will also be finding the domain and range of functions from a graph as well. Okay, so recall from earlier this unit that in order to be a function, the domain can only be paired with one element in the range. So basically, in order for it to be a function, we know that the x's or the x values can't repeat. From a graph, we can test this by drawing vertical lines. If it is possible to draw a vertical line that intersects the graph more than once, then it is not a function. So if we look at these examples below, in example 1, I can draw a vertical line here, and this vertical line is intersecting the graph twice. So because the vertical line is intersecting the graph more than once, number 1 would not be considered a function. So it's not a function because it does not pass the vertical line test. In example 2, no matter where I draw a vertical line, it's only going to intersect the graph once. So if I draw it here, or even if I draw it here, it only intersects the graph once. So therefore, because no matter where I draw that vertical line, it's only going to intersect the graph one time, this would be considered a function. So yes, it is a function because it passes the vertical line test. In example 3, again, no matter where I draw that vertical line, it's only going to intersect the graph one time. So therefore, this one passes the vertical line test. So example 3 would be considered a function. The last graph example here, if I were to draw a vertical line right here, this vertical line is actually intersecting the graph 3 times. So this one does not pass the vertical line test. So this one would not be a function because it does not pass the vertical line test. So use the vertical line test anytime you're trying to determine whether or not a graph is a function. Okay, so now let's review domain and range. Recall that the domain is the set of all x values. The range is the set of all y values. From a graph, we need to use interval notation to write the lowest and highest value for each. So the first thing you're going to do is label any key points on the graph and the direction of any arrows. So I'm going to highlight, this looks like a key point. It's a starting point of the graph, and then there's an arrow which indicates that this graph is going forever in that direction. Infinity symbols. So if a graph is going forever in a certain direction, we use the infinity symbols. And for infinity symbols in interval notation, you always use parentheses. If the graph stops or starts at a certain point, that number would be included in the domain and range, and we would use brackets for starting or ending numbers. So for this particular graph, think of the domain as how far to the left the graph goes and then how far to the right the graph goes, since the domain is the set of x values. So if I look at this graph, how far to the left is it going? It's stopping here at -2. So it goes from -2, and then how far to the right is it going? It's going to keep going forever because there's an arrow. So forever to the right would be towards positive infinity. So therefore, I'm going to put a bracket around the number -2 because I want to include that number. And then we always use parentheses around the infinity symbols. For the range, since that's the set of all the y values, we're going to look at how far down the graph goes and then how far up the graph is going. So how far down is it going? It stops at +2. So it would go down to +2, and then it's going upwards forever because this is slowly going to be going further and further in the direction upwards. So forever upwards is towards positive infinity. So again, we would put a bracket around the +2, and we would put a parenthesis around the infinity. Again, to review, the domain is how far to the left the graph is going, and then how far to the right the graph goes. Range is how far down the graph is going, and then how far up the graph is going. And then the last thing we're going to look for is, does this graph pass the vertical line test? And it does. So therefore, this would be considered a function. So let's try some more examples. I have 8 examples on the next couple of pages for us to practice finding the domain and range and then determining whether or not the graphs are functions. So in example 1, just remember domain is the x value. So how far to the left is the graph going? How far to the right? There are arrows on both ends. So technically this graph is going to go forever to the left. So forever to the left is considered negative infinity. And then how far to the right is this graph going? Well, since there's an arrow, technically it's going to go forever towards the right. So that would be towards positive infinity. And then just make sure you put parentheses around both. The range is the set of y values. So first we're going to look at how far down the graph is going. And since there's an arrow, technically it's going down forever. So if it's going down forever, it's going down towards negative infinity forever. And then how far up is the graph going? Since there's another arrow, it's technically going to keep going upwards forever. So upwards forever would be towards positive infinity. And then make sure you put parentheses around both. Last thing I'm going to ask myself, does this graph pass the vertical line test? And it does. So yes, this graph would be considered a function. In number 2, if I look at this, how far to the left the graph is going, notice there's an arrow, and this U-shaped parabola graph is going to keep getting slightly wider and wider and wider. So it is going to go forever to the left, which would be forever towards negative infinity. And then same thing on the right-hand side, the U is going to get slightly wider and wider. So it's technically going to go forever to the right. So that would be towards positive infinity. And then for the range, how far down is the graph going? It's going to be going forever downwards. So forever downwards is towards negative infinity. And then how far up is the graph going? It's actually stops right here at +6. And since we have a number, we always put our numbers with a bracket. And then does this graph pass the vertical line test? It does. So yes, this graph would be a function. In example 3, again, how far to the left is the graph going? It's stopping here at -6. And then how far to the right does the graph go? It stops at +6. So we're going to put brackets around both of those numbers since it has a starting and a stopping point. With the range, how far down is the graph going? It stops at -2. And then how far up does it go? It stops at +2. And then does this graph pass the vertical line test? It does not, because I can draw a vertical line that's intersecting the graph more than once. So that's why it's not considered a function. Okay, then example 4, again, how far to the left is this graph going? Well, it's technically going to keep getting wider and wider to the left. So it's going forever to the left. So that would be towards negative infinity. And then since there's an arrow on the other side, it's going to also go forever to the right. So forever to the right is towards positive infinity. And just make sure you put parentheses around both. For the range, I'm going to look at how far down the graph is going. It's going down to -4. So I'm going to put a bracket around -4. And then how far up is this graph going? It's going forever up. So forever upwards is towards positive infinity with a parenthesis. And then does this graph pass the vertical line test? Yes, it does. So number 4 is a function. Okay, last page has 4 examples. So for number 5, how far to the left is this graph going? Well, since there's arrows, it's going to keep getting wider and wider to the left. So it's going to go forever towards negative infinity. And same thing on the right-hand side, it's going to keep getting wider and wider, so go forever to the right, which is towards positive infinity. How far down is this graph going? It's going to go forever down, so forever towards negative infinity. And then how far up is the graph going? It's stopping here, so it's going up to this point here, which is 0 with a bracket. And then does this graph pass the vertical line test? Yes, it does. So number 5 is considered a function. Next example, example 6, how far to the left does this graph go? It stops here, which is at negative 4. And then how far to the right is it going? Since there's an arrow, it's going forever towards the right, which is towards positive infinity. For the range, how far down is this graph going? Well, technically, it's going to keep getting wider and wider as it goes downwards. So it's technically going forever downwards, which is towards negative infinity. And then how far up is this graph going? It's stopping here at positive 2. And then does this graph pass the vertical line test? Yes, so it would be considered a function. All right, we got 2 more examples left. In example 7, how far to the left is this graph going? Well, with the arrow, it's going forever towards the left, which is towards negative infinity. And with the other arrow, it's going forever to the right, so towards positive infinity. Then for the range, how far down is this graph going? It's going forever downwards, so forever towards negative infinity. And then how far up does the graph go? It stops here at positive 4 with a bracket. And then does this pass the vertical line test? Yes, so this would be considered a function. Last example, example 8, how far to the left does this graph go? It goes to negative 3. So I would put a bracket around negative 3. And then how far to the right does it go? It goes to positive 3. Then for the range, how far down is the graph going? It's stopping at negative 3. And then how far up does it go? To positive 3. And then does this graph pass the vertical line test? No, because I can draw a vertical line that's intersecting the graph more than once. So hopefully now you have a better idea of how to determine whether or not a graph is a function using the vertical line test and how to find the domain and range from a graph. If you have any additional questions, just reach out to your teacher.